I think Martha Farah needs no introduction. Very famous psychologist and neuroscientist. I'll not read her huge CV. I'll just say that a very curious fact about her formation and her career is even being this so famous, important, relevant psychologist and neuroscientist, she was an undergrad in philosophy too. So it's a pleasure. I'll think I'll summarize the importance of Martha Farah to our field as one of the founding mothers of neuroethics. I think that's as precise as could be. It is a pleasure to receive you, Martha. Thanks a lot for accepting our invitation. And without further ado, let's hear from Martha Farah. A big round of applause.
Thank you. So thank you, Gabriel. I really appreciate this invitation. As you noted, as an undergraduate, I studied philosophy, and I've always kind of had, a secret desire to do philosophy, which, I haven't really done, but I'm thrilled to talk to philosophers here. And I look forward to questions and discussion later. Okay, so as promised in the abstract, I will talk first a bit about SES and this new approach to understanding it with neuroscience, and then turn to the ethical implications that might be drawn from it. So let's first start with SES. Yes, start with SES, beginning with defining it and why should we care, and what do we know about SES in the brain? Okay, what is SES?
Let me make a comment, Martha. I
Sure.
think your presentation is very important as well, considering that this meeting is in Brazil, when we have terrible maldistribution. I think it's even more relevant,
Yeah. Well, I have to say, my ignorance of poverty is greatest when it comes to non-US, non-high income country poverty. So I will learn from you all. It may well be that there are regional differences. That would be a really good question to try to understand. I suspect a lot of the underlying principles are the same, but thank you for noting that. Okay, so first of all, socioeconomic status is a continuum from very low to very high. It's measured by, maybe even defined by, a number of factors: income, wealth, education, occupational status, neighborhood characteristics, and so forth. And they are all correlated, as you might expect, not perfectly correlated though, which is why often people use composites of some sort. Or if they have an interest in a particular factor, like neighborhood characteristics, they select that. Okay, so
Professor, sorry, we still can't see your slides. So if you're
you're kidding. Oh, yeah. Okay. Oh, you know what? I think I must need to screen share. Thank you for telling me that. Oh, okay. Share screen. That I think.
It's right at the bottom. Yeah, there we go.
Okay, awesome. And
it's
now,
just not full screen.
Yeah, let me see if I can do that.
F5 might do it.
I'm sorry, what did you say?
F5. You may. Yeah, there we go. Now it's working.
Does that work? Okay, great.
Yeah, great.
So, okay, what is SES? We just covered that. And what is poverty? You know, for most purposes, it's the extremely low end of SES, although poverty, strictly speaking, is measured by money. But as we've already observed, there's correlations between money and other measures. The US poverty line, again, less relevant down there maybe, but is quite low, you know, under $30,000 for a family of four. And you know, there's a lot of poverty in the US, which, considering how rich our country is, you know, a little disheartening. And it's also observed that poverty is most harmful to people, but SES effects do exist at all levels, which is a little surprising. You know, why should the difference between lower middle class and upper middle class impact well-being, health, etc.? It's not well understood, but there you go. Those differences, though, between, like, you know, middle and upper, they are smaller than the differences between poverty and non-poverty, or between the deepest poverty and less deep poverty. Okay. So why should we care about this? Well, it turns out poverty, SES in general, poverty specifically, does impact. By the way, do you see a menu bar here on the slide? I'm gonna just put it over here in case it is visible to you. Okay. Okay, so what you're looking at here is a bar chart of the percentage of people in the province of Ontario in Canada several years ago who reported symptoms equivalent to diagnostic criteria for major depressive disorder. So, you know, loosely speaking, this counts who was depressed in the past year. On the x-axis, we see the income decile, with 1 being the lowest 10% of earners, and 10 being the highest 10% of earners. And as you can see, there is quite a dramatic difference here. Being poor means you're substantially more likely to be depressed in the past year. We've got, you know, 14% and a bit here. We've got approximately 5% here. I mean, that's almost a threefold difference. You can also see, by the way, the steeper effects at the poverty end and flattening out at higher levels of SES. Okay, so one reason we should care is emotional well-being. Whoops. Oh, okay. There we go. Another reason we should care is that there's a strong association between poverty and all kinds of capabilities, including intelligence as assessed by IQ tests. This data is from a study that looked at family income in early childhood. It's a kind of funny scale here. They're using multiple of 1982 minimum wage in whatever state they were in, I suppose. And so this is in early childhood. This is, I believe, at age 25, in any case, young adulthood. So these are long-range effects. And you can see that we go from a mean IQ of 91 for the poorest families, the poorest children, to 110 for the wealthiest. So we've got, you know, more than a standard deviation in IQ, showing differences as a function of SES. What should we conclude from this? Well, both emotional well-being and intelligence are functions of the brain. This suggests that SES is linked to the brain. Okay, now, given the effects of SES on emotional well-being and capabilities, clearly this topic has ethical aspects, and we're going to get to that next after doing a quick review of what's known so far in neuroscience. So what do we know? Well, I'm going to do a brief flyover of current SES, SES neuroscience, I should say. I am not going to do justice to it. I'm not going to give you all the nuance. I'm really going to just, yeah, it's like a flyover, 35,000 feet. Okay, first of all, there have been structural brain differences found in children and adults, excuse me, as a function of SES. Volume, cortical surface area, cortical thickness, white matter integrity. These structural features have all been studied. What we see here is data. None of these. Oh no, actually, that is okay. This is data from Kim Noble, looking at surface area, cortical surface area as a function of SES. And you can see there are effects. You can also see they're fairly widespread. This is from research I've done using the UK Biobank, which is, you know, middle-aged and older adults. This looks at volume, cortical volume as a function of SES, with the, you know, highlighted area showing the biggest effects. And this is from my colleague, Allison Mackey, showing cortical thickness differences in middle school aged children. So, you know, do these things superimpose perfectly? No. Well, we might not really expect them to. Thickness and surface area are different. You might expect them both to align somewhat with volume. One issue that I'll return to in a moment is that, you know, this is early days, and not everything hangs together perfectly yet, which is frustrating, but kind of what we need to be aware of. Okay, functional brain differences. fMRI showing, you know, task-specific activation, functional connectivity, usually measured at rest, event-related potentials. This is just showing some fMRI bold activity during an emotion regulation task, and the colors represent places where there are differences between people. This is adults, people who experienced childhood poverty, and people who didn't. This is an ERP study by Courtney Stevens, Helen Neville, and so forth, showing that in an attention paradigm, there are differences between attended and unattended text read aloud. But there's an animation here. So this is high maternal education, and you can see here that the gap between these peaks represents the effect of attention, comparing unattended to attended. But it's where it should not be there. Lower maternal education, which again, that's one of the correlates of SES, and it's a rough and ready measure for many purposes. You see much less of an attention effect. So these are all ways of looking at functional brain differences. This is like the parting, this is the final slide on SES neuroscience. It really was a brief flyover. But I want to mention that these neural correlates that I've just showed you pictures of and mentioned, they have some relevance to SES-linked psychological outcomes. How do we know that? Mainly from mediation analyses, where people like the Kim Noble study, for example, she also used test performance in a variety of tests, cognitive tests. And she asked the question, do the brain differences we see correlate with the structural, correlate with the cognitive differences that we see? And they do, and they, what statisticians would call, mediate that effect. There are emerging, but still pretty rudimentary, understandings of the causes here. Why are brains different as a function of their SES? Of course, that's really, that's the thing that we most want to know, right? Because that would presumably enable us to protect brains from the harmful effects of poverty. And I just want to say, there is lots more to say. This is a burgeoning field with, it's not a finished product, not anywhere near. There are lifespan effects, differences between, early life, young adulthood, old age. There are probably sensitive periods. That is, poverty experienced at certain points in your life will be different from at other points. There are genetic effects that are contributing, but not solely responsible for some of the brain differences. And I just want to emphasize again, we're piling up findings, and we should probably try harder, but we're trying to relate them to one another. And of course, there are replicability problems. There always are. And it's especially acute when there are different possible measures of SES, different brain measures, and so forth. So just to go out of my way to not oversell what we know. Okay, so now let's turn to the ethics, which I am guessing is what the philosophers here care most about. Can neuroscience help prevent the harms of poverty? Or, perhaps surprisingly, does it compound them? Well, let me say there are different schools of thought on that. There are enthusiasts who say, yes, we can help poor people by understanding exactly what's going wrong in their brains to make them happier and more capable and all kinds of other good things. They sometimes use language like, we can finally look under the hood of the car and see what's really going on. There are others who say, what difference does it make whether you know stuff about the brain or not? It's not really, it's not ethically relevant. It's not going to help you help the poor. You know, don't succumb to the everything has to be brain related trend. And finally, there are the alarmists who say SES neuroscience has ethical implications and they are not good. Okay, so I'm going to quickly zoom through the, one slide each of enthusiasm and people who say it's irrelevant, and then we'll go into the ethics. Okay, I'm going to flash up a bunch of book covers and face pages of reports and so forth, all of which apply neuroscience to social problems and poverty. Okay, this is a high-selling book. Another book about education of poor children based on brain science. This is part of the communication program of Chuck Shonkoff's program at Harvard. Here's a report advocating for investing in poor families and families with poor children. Again, clear, they're definitely taking a brain-based approach to the argument. This is a sort of rehabilitation and training program for women. This, this is from their pamphlet, their book. And you can see brain here is prominently featured. Okay, so the brain is getting a lot of PR and people are looking to it with great hope for, improving the lives of the poor. But some people say, why does it matter if the differences can be seen in the brain or not? This is a book, I don't know if I want to say I recommend it to all of you. If you want the most, the strongest statement of why all of these applications of neuroscience are useless, this is a good book to look at. It came out a few years ago. I think they make a lot of good points. I think they also overstate things a bit. And also, I think in some ways, even though it's probably less than 5 years old, it's probably a little out of date in terms of what we can do with neuroscience. But anyway, you could say, look, so what if it's in the brain? How does that affect how could that affect the lives of the poor? Well, here's some cases of the alarmists. And I want you to notice that each of these worries is distinct. I mean, some of them overlap, but there really are a lot of people who have given voice to the dangers of pursuing SES neuroscience. This is a really interesting book by my late colleague here at Penn, Michael Katz. And he argues against, putting the problems of the poor in biological terms. he says, look, are you going to feel better if instead of being told you're incompetent, lazy, and antisocial, being told you're biologically inferior? I mean, it's not clear that that's much of an upgrade. Yeah, and it's also kind of, what's the word? Objectifying. It's like damaged goods. No human being wants to be considered that way. Another worry is that when we talk about the brains of the poor and their ability to, for example, mediate SES and cognitive performance, which I mentioned earlier, we're in danger of essentializing poverty. Here's a quote from Millay and Joronen, who say, we are reinscribing social and economic differences into differences in brain architecture. Yeah, so we're kind of changing the packaging, but we're making it, social and economic differences are outside of the person. Differences in brain architecture, that's the kind of person you are, which is the dark side of essentialism. It's also been pointed out that the SES neuroscience work imposes, kind of sneaks in middle-class values. So, for example, there's a lot of work on executive function as a function of socioeconomic status. That is a pretty, talking about like what replicates and what doesn't, that is a highly replicable finding. And as you may remember from the brain pictures, the brain structure pictures I put up there, there's differences in prefrontal cortex. So perhaps it's not surprising. Well, Thornton and his colleagues say, why are we so concerned about executive function, self-control, and so forth? He, or perhaps she, I think that's a he, says the discourse of brain science affirms middle-class values and lifestyles by invoking cultural practices and preferences specific to this group, to the middle-class group, talking, for example, about being able to delay gratification, stay organized, all those frontal lobe type things. In the discourse's explication of the ideal environment for stimulating neurological development. This is in response to sort of brain-based advice on parenting and early childhood education. Another moral issue that I think needs to be taken seriously is talking about the brain is a distraction from the important goals of relieving poverty. So one person said, instead of confronting issues of equity, power, and justice, we instead focus on the impact of the environment on brain function. Okay, that would be bad if we considered it either or. And I find this remark really, striking. This guy says these analyses of, oh gosh, poverty impacts the brain, how terrible, is like saying slavery is morally wrong because it impacts brains. And I think that bears thinking about. And it's basically, I think, related to the first comment, which is, understanding the role and the mechanisms of the brain in poverty does not say we should ignore the external structural features of our society that make it so hard on the poor. Finally, the brain science can invite a kind of fatalism, like, oh, it's hopeless, their brains are bad, what can we do? So this is Anne, I think her name is Anne Hurlburt. If young brains subjected to deprived conditions and to the inadequate parenting that often goes along with them are irrevocably damaged, pickled in stress hormones, stripped of synapses, there is no time to waste. That is true. Okay, so yeah, this has been a favorite refrain of people trying to get more resources for young families. But she goes on to say, such alarm, though it conveys urgency, can all too easily fuel defeatism. The case for subsequent help is bound to seem weaker. So if we look at, middle schoolers, teenagers, adults, what happens if we conclude that, oh, there's all this early developmental stuff that goes poorly because of the environments, because of the environment of poverty. So now what can we do? They're damaged goods. Okay. Well, I'll be interested in hearing what you think about these worries. But let me tell you my conclusions. First of all, SES neuroscience has made progress in understanding the harms of poverty and how they're manifest and a little bit in what might be causing them. But it's limited progress. Then again, I want to defend my field by saying limited progress, it's 20 years old at the greatest, probably less than that. No problem, disease like autism or any other problem, is going to be cracked in a couple of decades. I mean, look at how long we've been studying the neuroscience of autism. Many decades, and look at how many different labs are focused on the neuroscience of autism. Do we have an explanation yet? Do we have treatments yet? No. So I think patience is needed. This is all a long game. But finally, I think we should, in response to some of the alarms that were raised, I think we need to consider neuroscience one more vocabulary and set of tools for understanding and trying to help the poor, but not the ultimate tool. We're not saying, oh, forget about everything else. The only thing that matters is the brain, and not redefining people as objects, as brains, or, essentializing them into sort of non-individual cogs in a big impersonal machine. And with that, I thank you for your attention and would be very happy to take questions. Thank you.
Okay,
Maybe
thank you
I
very
will-
much, Martha, Professor.
Yeah.
Okay, we have one question here.
Can you hear me?
Yes.
Oh, hi. This is Peter C. We actually met in like 92 or something. You gave a talk.
Oh, yeah.
at the
I
bottom.
remember. I
think
I
you
was interested to see your name on the.
Yeah. I think I last heard you talk in person in the basement of William James Hall in 92 or 93.
Oh my God, that's
It's
a
all
long
been a long time ago. But
Yeah.
but you'll remember that there were people in our department like Dick Herrnstein who basically said, well, all you have is correlations, but really the causation is that low intelligence people end up poor. And
Yeah.
right. And so you're dealing with that mentality. which I think is very harmful. Um, and I think the best kind of evidence against the bell curve sort of approach, the right-wing approach, essentially blaming the victim, is the work of Marion Diamond that looked at
Yes.
rats, right? And so she gave them enriched environments, impoverished environments, and showed radical differences at this, at the level of neurons in terms of dendritic arborization and so forth. And it had analogous outcome differences between SES, right? Whether rats were well mothered or not well mothered, or enriched in their environment or not. So, and these were genetically identical rats, right? So you can't go and
Right, as rats usually are in these research projects. Yeah.
Yeah. So
No.
we need to short circuit the bell curve attack, right? That says they're dumb and therefore that's why they're poor, right? But then the question is what to do with it, right? I mean, have you specified policies? Because my worry is that so much of this stuff happens before the age of kindergarten. The effects of poverty, impoverishment in diet, impoverishment in social interaction, and so forth. And how does a society go down to the preschool and preschool ages to make a difference? I mean, there are counterexample societies, right, like Scandinavia, Germany, and so forth, that invest a lot of money into these first 7 years. But we don't, and we pay a huge price for it.
Yeah.
So I'm just
Yeah.
interested in hearing about your policy recommendations.
Well, let me respond to a few of the things that you said, because they're all very interesting and right on point. First of all, the Herrnstein and Charles Murray, point of view, and Steve Pinker maybe a little bit too, is that we've, basically the capacities that we measure and find lower in low SES are plausibly genetically influenced. I think Bernstein might even say, determined, or, Murray, but, and so parents who have these not very good genes, let's say, I kind of hesitate to even say words like that. It sounds, not nice, but parents with genes for depression, low intelligence, etc., drift down in socioeconomic status, because both of those are traits, and there are many others that affect how well you do in life and your ability to get an education, keep a job, etc. So they drift down and find, their sort of natural level given their innate abilities or lacks of ability. And then they have children, and those children, of course, have genes from their parents, and they're raised in poverty. They spend their life in poverty. And so, Charles Murray, who a book or two ago, he writes a lot of books, he wrote a book called Human Diversity that had, I think, at least one whole chapter on social class differences. They would say, look, this is what's behind these correlations that you're pointing out, right? And that's exactly, Peter, what you just said. First of all, let's just say it's an empirical question. It would be really depressing if all of these different, unfortunate outcomes were 100% genetic. I mean, I'm not sure we would be bad people if the evidence is really clear, for saying, look, the evidence is that it's genetic. Let me put a bookmark there for a second. But it's an empirical question. And people have done work that's relevant to that, including on the brain structure front. So that middle picture of like two brain slices that I showed to illustrate structural brain differences as a function of SES, that was from a project that I did with Phil Kohlinger and various other people who know a lot more about genetics than I do. Okay, it's UK Biobank, so we have, brain scans on like 30,000, actually more than that now, but when we did this, that was the number. And all of them, virtually all of them, had full genome scans. And so we constructed a polygenic score for socioeconomic status, and they looked to see what the brain pattern associated with genetically influenced socioeconomic status was. And then we looked at SES in the brain, and then SES minus the influence of genes. And it was very interesting. The differences did not go away, and possibly more interesting. I mean, they were cut back substantially in some areas, and they were untouched. They were virtually untouched in others, which suggests that in terms of the brain, genetic influences on SES are unevenly distributed, which I guess shouldn't surprise us. But I take this as very good evidence that the whole story is not genetic. But moving on to the second part of your question, which I think is, also very apt. What do these findings call on us as a society to do? Which is, I guess, a sort of more philosophical way of talking about policy implications. Well, here's the thing. Something being genetic does not mean that it is immutable. When you bring your child to the hospital and they say, oh my gosh, all this bleeding is because he has hemophilia, potentially deadly disorder. And it's also genetic. The doctors do not say, oh, sorry, he's got hemophilia, that's a deadly disorder, and it's genetic. So there's nothing we can do, take your kid home, right? I mean, just because things are genetic, you can still push them this way and that using environmental interventions. So for that reason, I think the Murray-Herrnstein, it's pointless, why even try argument, because it's all genetic argument falls apart. It falls apart partly because we know it's not all genetic, and partly because even if it is all genetic, interventions can help. And you said a lot of interesting things. I don't know if I've covered all of them or...
Let me just add to what you said there, that IQ, about 50% of the variance seems to be accounted for by genetics. I mean, as measured by these monozygotic twin studies. So
yeah.
50% is genetic. That means 50% is not genetic. It's due to other factors, whether the environment or your own decisions. Now, I think so Herrnstein and Murray made a couple of mistakes. One is to confuse an is with an ought, right? Where they said, well, they're genetically lower IQ, therefore we should not waste money on them. But you could have equally made the opposite claim, therefore we should spend way more money. But setting that aside, I think the fundamental error that these right-wingers make is to say that what is genetically given is outcome, but what is genetically given is a potential. And how that potential turns into an outcome depends on many factors, including
Yes.
education, the scaffolding afforded by your culture and parenting, and also your own decisions, in terms of how you will realize your potential. And I just think other societies have that view much more so than we do. We in a way have a much more fatalistic view, whereas in Scandinavia or the German-speaking countries, they view children as full of potential, and the goal of society is to help each child realize that potential. Yeah, so our society is quite cruel, I think. All right, I'll let someone else speak, but thank you so much for your talk.
Yeah, well, thank you. And I'll just say one other thing about heritability measures, because you were talking about, IQ is 50% heritable, and so forth. Heritability is defined relative to a population, right? It's just like what percentage of the variance in that population is accounted for by genes. And a behavioral geneticist named Eric Turkheimer did a really interesting study where he separately analyzed the twin data from higher SES twins and lower SES twins. And he found differences in heritability. At high SES, the intelligence was essentially completely heritable. Would not be too much of an exaggeration to just say it's all the genetics. And at very low SES, it's barely an exaggeration of his results to say it's all environmental. Now, what does this mean? Well, I think what it means, and you were saying, it's all about how the genes get to be expressed in a certain environment. High SES kids are kind of at ceiling on how intellectually nurturing their environment is. So they've all got good enough environments. So any differences that we see will be genetic. On the other hand, lower SES kids grow up in an environment with huge variance from literally no conversation with parents, and harsh punishment and no toys to play with, to the sort of happy storybook scenario of they're poor but they play games and they talk about things and take walks because that's all free. And so for the poor families, you find IQ being driven by the environment, which I think just illustrates what a slippery topic heritability, or what a slippery concept heritability is. And I also want to say, in European countries, that effect is less apparent because, Peter, as you were saying, most countries provide some kind of minimally adequate environment for raising kids. There's also just there have been replications, there have been failures to replicate, so I'll just leave it there. And thank you. I'm ready for the next question, and thank you for your attention.
Hi, Martha. It's Eddie Namias. Can you hear?
Oh, hi. Yes, I can hear you.
So I was going to ask a question about brain images in the public and sort of how they might have good or bad effects in the same way they do in neurolaw, or variable effects depending on what you show. But now you can talk about that, but I want to suggest that, kind of picking up on your conversation with Peter, to avoid the essentialist and fatalist objections, which I think are real and problematic in any kind of neuroethics area. In this area, what it seems like what we would really want is brain images that show the public change, right? The change that you get when you enhance a child's environment. So picking up on the rat studies, right? So if somebody could like first do the study, which wouldn't be hard to do, like look at kids before and after pre-K, free pre-K, or more exposure to language because of some intervention, and then just do like some interesting fMRI or EEG or something that would just show the public pictures of how, look how much more activity there is. I feel like that would be the perfect public policy and initiative to help people avoid both the essentialist worry, right? It's not it's not just genetics. Look what you can do if you change environment. The fatalist worry, and the objectivism worry, because you could probably also put this in the context of, making it clear how much happier the kids are or whatever, and they're increasing their own cognitive capacities. So anyway, anything you want to say about the power of brain images? I don't actually know the latest literature on that and whether people are seeing bad or good effects from images depending on what you do with them, and then maybe this specific suggestion of how to use them to avoid fatalism and essentialism.
Fantastic. I mean, I have to say, first of all, these are the greatest questions. I really appreciate them. My sense is that the seductive allure of brain images has been overstated, and several groups that I know, including my own, have done research that didn't find that. Now, some people have said, well, maybe the public has gotten more sophisticated, or who knows. But I definitely agree that showing a change in the brain as imaged would be a powerful way of arguing for, supporting interventions. I mean, it's kind of cool because you'd be, sort of using the very tool that has raised concern to overcome those concerns. Let me say, there isn't a lot of work that has done that, but there is some. I'll mention mine first. There was a really fantastic intervention effect done starting in the 70s, late 70s, I think, in North Carolina, called the Abecedarian program. This was from essentially birth. I mean, they enrolled kids at, 3 weeks to age 5, and or kindergarten, whichever came first, I guess. First or second, I'm not sure which. And they targeted low SES kids at risk for, poor school performance, etc. And these kids went to an all-day center-based daycare that was designed to be cognitively stimulating, used a lot of language. In fact, the curriculum was based on what they called language games. And at each age, there were things that the workers did, so with infants, they would just carry them around and show them things and talk about what they're seeing, and it was really beautiful. It was very expensive. But they also had a control group, which is also fantastic. And the control group thought they were in the intervention because the control group got the same nutritional, early life nutrition formula. None of the families went for breastfeeding. they got, free formula, they got enhanced access to medical care, social workers, et cetera. So, so there was, I think a pretty good comparison between randomized groups that differed only in this cognitive linguistic intervention. When these people were, I think in their 40s, anyway, they were adults. They were adults. Reed, Montague, and I, along with the Ramies who developed the abecedarian intervention, scanned as many of the, alumni of the abecedarian program as we could get to Roanoke, Virginia, where Reed has his multiple scanners. And we found differences in brain structure that were, significant, doing all the corrections, all that kind of stuff, and we're in places that you would expect cognition and language experience to target. So let me see. The regions of the prefrontal cortex, I think, were they all prefrontal? No, and then some temporal regions, hippocampus, which we didn't see anything in. So basically, it's possible to do these things. This was not easy. And Eddie, I had the same, I expected people to go, what? Oh, this is really, anybody who is susceptible to the seductive allure of brain images, you would think, we had a horrible reviewing experience with PNAS. It was truly horrible. And then we just sent it to Journal of Cognitive Neuroscience because I was sick of waiting for months and reanalyzing umpteen ways. Our joint communications offices, put out Eureka alerts, but nobody picked up on it, and it's not well cited, which is very disappointing. I will tell you about another study done by Jean Brody and colleagues who, I wish I could remember exactly where they are, somewhere in the South, called the Strong African American Families Project. This intervention targeted young teens, and there is some evidence that adolescence is a second sensitive period for the brain. And unlike the abecedarian, which went on for 5 years, this was like a few weeks. I mean, it was like insanely short. And it basically, they intervened with the parents and with the kids, targeting the social skills that kids need to resist, risky activities, drug use mainly, also unprotected sex, and also how to respond to racism. And this was very effective in terms of the behavioral outcomes. And then Brody and collaborators started imaging these people, and they found differences in the hippocampus, which is interesting because, the hippocampus, I mean, we know it from like memory and KCHM and all that stuff, but it's exquisitely sensitive to stress and trauma and hardship. And of course, the SAF intervention was really, zeroing in on those components of life in poverty. Anyway, that's, I think.
Hello. Martha,
Hi.
I have
Yes.
a question myself, Gabriel
Oh,
speaking.
fantastic.
I wanna present you a real scenario for real scenario in which a real character, describing here a real character. Imagine this is a Brazilian woman. She works as a house cleaner. She lives in a slum, in a favela. She commutes 3 hours and 30 minutes from her home to work. She wakes up 4:30 to be at work at the proper time. She lives in a slum that have crossfire between elite troops from the police and drug dealers. So she has very poor sleep, not very recovering. And she commutes 3 hours and 30 minutes, probably standing in an illegal van, then a train, a packet train, and then a bus. She's pregnant. Probably her levels of cortisol are beyond the roof.
Yeah.
What are the impacts we have in the brain of the newborn? What kind of epigenetic hindrances this newborn would have? And now comes the question, the neuroethical question. How much of legal exculpation, of attenuation, a crime committed by this guy when he's 16, 17, will be reasonable? That's my question.
Whoa, that's a lot of weighty issues packed into that question. Before we get to the legal responsibility question, let me just say that sleep is known to vary as a function of SES. Low SES people tend to have less time to sleep, and they tend to not sleep as soundly because of noise and crowding and so forth. But going to the stress effects on the fetus, yeah, I mean, there has been work on prenatal effects of SES, of low SES. Of course, there's SES, poverty, and then there's the specific factors, the active ingredients, which, you're pointing to stress, and I think that very much is an active ingredient. There has been work, and I am struggling to remember the guy's name, but there has been work by a guy who he's in-house at NICHD at NIH, but he also has an appointment at the Harvard School of Public Health. I don't know if that's going to narrow it down. He has done work on the effects of stress and cortisol levels on later child development. And he has specifically looked at SES in that context. And obviously I can't remember his name, so I'm not going to remember his findings in any detail either, except to say that stress differences are relevant to child development in different, prenatal stress differences are relevant to child development across SES levels. And many of these factors synergize, and there's reason to believe that, for example, one study, not by this fellow, by a group at Columbia, whose names I also can't remember, it's been a long time since I read this stuff, found that there's a synergy, there's a super additive effect of low SES and air pollution on the fetus that is detectable in later childhood. So, yeah, kind of a depressing note to end on.
Okay, thank you.
But thank you for these great
Okay,
questions. Yeah.
great. Thank you very much, Professor. Now we. Is there any? Okay, so we have another question.
Hi, Martha. It's not a question. It's just a very good example of this is this serotonin reuptake associated gene that has a long and short allele. Have you heard about this one?
Yeah.
And if
Yeah.
you're born with 2 long alleles, I believe it is, you'll end up being quite hardy. You know, even if you grew up in war-torn Beirut in the 1980s or something. Whereas if you have 2 short, you're very prone to developing anxiety disorders and so forth. But there's an interaction with the environment. If you're not subject to stress, you'll be fine. But especially in this window of like 7 to 11 years old, if you're exposed to stress such as divorce or war, you will very likely develop depression, anxiety disorders. So, right, so having a certain genetics is not a sentence, but it gives you the potential to develop this way or that. And SES, especially if it's associated with stress, will lead to different expression of that gene, which will have huge consequences for the rest of your life.
Yeah. Thank you. Thank you for that. And
Well, Marta, we want to thank you from the bottom of our hearts. It was an impressive talk. We're very glad that you accepted our invitation. It is really a pleasure and an honor to have you among us. A big round of applause for Marta Farah.